The other day, I learned something strange. Apparently, every 20 to 50 questions someone asks an AI system like ChatGPT, about half a liter of fresh water disappears. One small bottle. For questions. Which made me wonder, why does asking a machine a question require water? Because when we talk about AI, we use words like the cloud. And the cloud sounds light, weightless, almost magical. Information floating somewhere in the sky. But water? Water is not magical. Water is very physical. So I started wondering, if asking questions online drinks water, where exactly is the internet getting thirsty? And that's where things start getting interesting. At first, I assumed the explanation would be simple, like computers need power, power plants need water. That's it. End of story. That felt reasonable. But the more I looked into it, the less reasonable it seemed. Because the water isn't just used somewhere far away in a power plant. Sometimes it's used right next to the servers themselves, inside enormous buildings. Buildings that look like warehouses, no windows, no logos, just large gray boxes sitting in the middle of nowhere. If you drive past one, you might think it's a storage facility or a factory. But inside those buildings, there are thousands of servers, and those servers run the systems we casually call the cloud. Search engines, streaming platforms, social media, and, of course, AI. And these buildings get extremely hot. When you ask an AI system to write something, or generate an image, or summarize a document, thousands of processors start working. Billions of calculations every second. All of that activity creates heat. A lot of heat. Enough heat that the chips would literally destroy themselves if nothing cooled them down. So the system needs a thermostat. And this is where the water comes in. The most efficient way to cool these machines is something called evaporative cooling, which is a fancy way of saying you cool the computers by boiling water. Globally, data centers are estimated to use around 560 billion liters of water every year. That's roughly 224,000 Olympic swimming pools. And according to projections from the International Energy Agency, that number could double by 2030, mostly because of AI, which makes sense. Training and running large AI models requires enormous computing power. And computing power creates heat, and heat creates thirst. At this point I thought, okay, maybe this happens in places where water is abundant. Near lakes, near rivers, somewhere rainy. That would make sense, but that's not what's happening. In 2025, an investigation found that major tech companies like Amazon, Microsoft, and Google operate at least 38 data centers in water-scarce regions around the world, with 24 more planned. Some of them are in places like the Arizona desert, which doesn't seem like the ideal place for thirsty machines. And yet, that's exactly where they're going. Arizona is a good example of how strange this system can get. In recent years, parts of Maricopa County stopped approving permits for new housing developments. The reason? Not enough groundwater. The state said the water supply could not support more homes, so housing projects were halted. But during the same period, data centers were still being built in the area. Large ones, facilities capable of using millions of gallons of water. So in some parts of Arizona, the system basically said, we don't have enough water for houses, but we do have enough water for servers, which is a slightly surreal policy decision. And Arizona isn't the only place where this tension is showing up. In Aragon, Spain, protests broke out near new data center developments. People held signs that said, "Your cloud is drying my river," which sounds dramatic, but it also sounds oddly precise, because that's more or less what evaporative cooling does. It takes water from a local reservoir and releases it into the atmosphere. And here's the part that surprised me. When a city uses water like for showers or washing machines, about 90% of that water goes down the drain. It gets treated, cleaned, reused, but data center cooling is different. That water is consumed, evaporated. It doesn't come back to the local watershed, which means the supply slowly decreases one cooling cycle at a time. In some places, the scale of this becomes very visible. Take the Dallas, Oregon, a small town on the Columbia River. One company's data centers there consume over a quarter of the city's water supply, more than entire neighborhoods, which creates an unusual situation. A digital service used by millions of people around the world, competing with a town of human beings for water. And the town doesn't necessarily get to control how much water the machines use. But even that is not the full picture, because cooling the servers directly is only part of the water footprint. There's also something called indirect water use. The electricity powering those servers usually comes from power plants, and many power plants generate energy by boiling water to spin turbines. So if a data center claims to use zero water on site, that might just mean the water is being boiled somewhere else. Estimates suggest the indirect water use can be about 12 times higher than the water used directly inside the facility. So even an air-cooled data center might still be draining a reservoir. Just not the one next door. And the thirst actually starts even earlier than that. Before a server is ever plugged in, its chips need to be manufactured. Semiconductor fabrication is a very delicate process. Silicon wafers must be constantly cleaned and etched using ultra-pure water. Thousands of liters of it for a single wafer, which means the water footprint of AI begins long before the first prompt is ever typed. The machines are thirsty even before they exist. Now at this point, I wondered, why use water at all? Why not just cool everything with giant air conditioners? It turns out the answer is surprisingly simple. Yup, money.
Money! Money!
Water is cheap. Electricity is expensive. Running massive air conditioning chillers would require huge amounts of power. But evaporating water is extremely efficient. So for companies operating giant data centers, the cheapest cooling method is usually the one that drinks the most water, which means the economics of the cloud are partly built on the assumption that water will always be available and always cheap. If this situation feels a little familiar, that might be because we've seen similar patterns before. In the early 1900s, Los Angeles famously acquired water rights in the Owens Valley. Water was diverted hundreds of kilometers away to support the city's growth. The valley dried up, local farms collapsed. The water moved to where the economic power was. A century later, the pattern looks oddly similar, except the growing city is now digital, and the infrastructure fueling it is hidden inside warehouses. Another parallel comes from the crypto mining boom in the 2010s. Bitcoin miners searched the world for places with cheap electricity. They moved into small towns, strained local power grids, drove up energy prices. AI data centers are following a similar playbook, except now the resource being strained isn't just electricity, it's water. History also gives a more extreme example: the Aral Sea disaster. In the mid-20th century, Soviet planners diverted rivers to irrigate cotton farms in Central Asia. The goal was industrial growth, but the result was catastrophic. Over several decades, the Aral Sea, once the fourth largest lake in the world, almost completely disappeared, all because water was redirected to support an export industry, which is a reminder that large systems can quietly drain ecosystems for years before anyone realizes the scale of what's happening. Today, the impacts are showing up in smaller ways. Sometimes it's higher municipal water bills because cities must expand infrastructure to support industrial users. Sometimes it's housing shortages when new homes can't get water permits. And sometimes it's something even simpler: residential wells running dry because industrial pumping lowers the water table. There was also a case in Chile where an environmental court partially halted a proposed data center near Santiago. The concern was not electricity, it was water, specifically the local aquifer. The court argued that the project could worsen water scarcity in a region already affected by climate change, which suggests governments are starting to notice something. The cloud is not actually in the sky. It's on the ground. It's made of concrete, steel, pipes, pumps, cooling towers, and sometimes steam rising from a roof. Which brings us back to that strange statistic: every 20 to 50 questions, about half a liter of water. One small bottle. It's not a perfect number. Estimates vary depending on the system and the data center. But the idea behind it is real. Digital thoughts are physical events. They create heat. Heat requires cooling. Cooling requires resources. And sometimes those resources come from the same reservoirs people rely on to drink. The strange part is not that computers need cooling. That's normal. Machines always need infrastructure. What's strange is how invisible that infrastructure is. We call it the cloud, which makes it sound soft, floating, almost natural. But the cloud isn't floating. It's sitting in a warehouse somewhere, and it's quietly drinking water, sometimes from places that can't really spare it. Most of the time, we don't notice systems like this. They're buried under layers of abstraction. Apps, interfaces, Wi-Fi signals, everything feels frictionless and weightless until you start tracing the pipes. And then you realize something: the digital world doesn't exist outside the physical one. It runs on top of it, on land, on minerals, on electricity, and sometimes on rivers. If you found this interesting, consider subscribing for more explorations like this. That's it.